Hi, welcome into Advanced Python series. In today's episode, we're going to cover closures. A closure could be described as an inner function which, after creation, keeps access to non-local variables or variables out of its local scope in which it was created in. Let's start with a simple example. We will create a closure which simply prints a message. We start by defining a regular function. Let's call it our outer function, and for now, it's not going to take any variables. Inside of our function, I'm going to define a variable which is going to be our message. So let's say that our message will be I'm in a closure. Now, after we've defined our variable, we will actually create a second function within the first function, and we will call it inner function. And now our inner function is actually not going to take any variables as well. However, we will simply use the print statement and print out the message. And as you can see, our inner function can actually access the variable from the outer function. And that is because most of the time, functions, at least in Python, have access to almost all of the variables from their outer scope. So just like I could define a variable outside of this function, let's call it newVar and set it to 5. Our function could simply access the new variable newVar, which is a variable non-local to it, but actually it's a global variable outside of the function itself. However, it can be still accessed by our function. A similar thing actually happens here when we are defining an inner function, which then has access to the outer variable, which is outside of its own scope. A variable accessed in this way is called a free variable, or also often called a non-local variable. So after we defined our inner function, we actually have to tell our outer function to return the inner function so that we can actually use it. So now we will return inner function. And if I actually call our outer function now using outer function, you can actually see that it prints out I'm in a closure. This is the simplest example of a closure, and it does not present all of its possibilities. An often used explanation of why those are called closures is that they close over the free variables and they keep those free variables existing despite our outer function already being finished, because variables in Python don't stop existing as long as they have at least one reference assigned to them. So now let's go over to a better example which actually uses a list. We can remove our new variable and our message variable, and now that we've cleared some space, we can start with our second example of defining a free variable list which will be used within our closure or our inner function. So we can start by defining our list, which in my case will be a fruit list, and it will be defined in our outer function. However, now going to our inner function, it will take in a variable called fruit, and inside of it now we will actually use our fruit list, which at this point becomes a free variable because it is taken in from the outer function, and we will append our fruit. And now to finish that off, instead of returning a function call, we will simply return the function without calling it by removing the brackets. We can print our fruit list after we're done appending the new value. So if you have used functions before, what you would expect to happen here is each time you call the function, it will simply print out the fruit, and then when it's finished executing, it will forget all of the values it had, all of the variables it had, and then when you're calling it the second time, it would create new variables with new values. However, that is not the case with closures, at least not in this scenario, because what you can actually do is you can create a new function without the define word. So let's call it fruit append, and we'll make it equal to outer function. And because we're calling the outer function, we are setting our fruit append to be whatever is returned from it, and what we are returning from it is the inner function, which is not being called yet. So now our fruit append is actually our inner function, which takes in the variable fruit. And now that we've done this, we can call our fruit append as many times as we want by simply calling it like a regular function. We have to pass in a parameter. So let's say we will give it an apple. Let's copy it over 2 times. And instead of an apple, let's use an orange and a grape. And what will actually happen now is with each function call, our values from the fruit list will be taken and memorized and then appended to with each iteration of our function, rather than being forgotten and creating a new list each time we call the function. So if we would run the file now, you can notice that the first time it says apple, then it says apple orange, and then finally it says apple orange and grape. And that happens because in Python, variables only stop existing once there is no references to them. So in a regular function, when it finishes executing, all of the variables are erased from it because there is nothing referencing them anymore. However, in this case, our fruit append function actually stores the free variable fruit list somewhere in memory, allowing us to constantly access the same variable without the need of using global variables. So now let's try a slightly different example. Instead of a fruit list, we will create a counter and we will set it equal to counter input, which will be our parameter from the outer function. And now our inner function will not be taking any parameters. However, it will take our counter, and with each iteration of inner function, it will append 1 to it. So counter plus equals 1. However, now because we're actually modifying the value from our inner function and not just reading its value, we have to specify using the keyword non-local that we're actually using a non-local variable, or also called a free variable. And now that we've specified it, we can append to our counter as we want. After appending, let's print it. So print counter. So just like in our previous example, we will now create a new function. Let's call it myCounter and set it equal to outer function. Now our outer function takes in a variable called counter input, and we will create a counter which starts at 100. So if you understood everything, you should be able to tell that myCounter will be appending +1 to our value 100 with each call of it, and it will keep that value and keep appending to the same one. We can test it by calling myCounter multiple times. Let's say we'll call it 3 times, and we will be able to see that if we run it, it prints out 101, 102, and 103 because the closure remembers our free variable. However, what's interesting now, and is something you can't really do with global variables, is that we can create a second counter from the same function and the same closure. Let's call it myCounter2 and set it equal to outer function again. However, this time, let's set our counter to be 0. So what happens now is actually we are creating 2 free variables which can be referenced separately. So if we call our counters interchangeably, myCounter2, and let's call it one after another, you will be able to see one of our counters starts from 100 and counts upwards, and the second counter starts from 0 and also counts upwards. And that happens because each of our counters creates its own instance of that free variable. So if we use the same closure object, myCounter, constantly over and over, it will keep appending to itself. However, if we create a new closure, myCounter2, it will have its own separate value. Closures in this case behave very similarly to classes, and you could create a class with the exact same functionality as those closures have. In smaller examples, it might be easier to use closures instead of classes. And that would be it for today. Yeah.